Hi, welcome to our next level 3 integration video. In this video, we're going to discuss and look at a technique called integration by inspection. We're going to get straight into two examples and show you this technique. It's quite a tricky technique. It basically looks at functions and seeing if you can spot things that are going on. And if you don't quite get it, watch the video a couple of times and practice and practice and practice until you're feeling better. All right, example 1, we're going to integrate 2x times e to the power of x squared plus 5 with respect to x. Well, the answer is e to the power of x squared plus 5 plus our constant c. So how did we get our answer? And what happened to the 2x? Let's take the function y equal to e to the power of x squared plus 5 plus c, which is our answer, and let's differentiate it. So what happens? The e to the power of x squared plus 5 differentiates to itself. So we get e to the power of x squared plus 5, but then we must times by u dash, which is the derivative of u. And u is x squared plus 5. And x squared plus 5 derives to 2x. So that's why we times by 2x. It's a composite function. And don't forget our number by itself when we differentiate will disappear. We're just going to take the 2x and put it out the front and get y dash is equal to 2x times e to the power of x squared plus 5. And then you may realize that's where the 2x's come from. It's the composite function of u dash. So that's why when we integrated it, it disappeared. All right, let's try our second example, our last example, a little bit trickier, and let's see if you follow what's going on here. We're going to integrate 4x minus 1 all times by the sine of bracket 4x squared minus 2x with respect to x. Well, we pull out our formula sheet. We know that sine integrates back to sine integrates back to negative cosine because a negative sine integrates back to positive cosine. So a positive sine integrates back to negative cosine. So that's why we're going to get a negative in our answer. And we're going to get half times cosine of 4x squared minus 2x. Now we'll talk about the half shortly, but don't forget to plus your c. Now you're probably asking yourself, first of all, where's that half come from and what's happened to our 4x minus 1? Well, once again, let's go back and differentiate this function to see if you can spot what's going on. Here's our function y equal to negative half cosine bracket 4x squared minus 2x plus our constant c. Now let's differentiate this function. So the minus half cosine bracket 4x squared minus 2x, the cosine differentiates to negative sine, so that's why the negative will disappear. And we leave the 4x squared minus 2x inside the brackets. Now we must multiply by the composite function of u dash, which is 4x squared minus 2x differentiated. And that differentiates to 8x minus 2. And the c will just disappear when we differentiate. Now, if I take that 8x minus 2 and put it out the front with the half, you'll see that the 8x minus 2 will simplify down to 4x minus 1, because it's half of it, times the sine of bracket 4x squared minus 2x. Then you will see that the 4x minus 1 is why we've got this out the front. This is the u dash. So when we integrate it, that's why the 4x minus 1 disappears, but it's half of u dash, which is why we get a half out the front. Pretty tricky, but the more of these you do, the more confident you'll feel you'll be able to just look at a function, inspect it, and be able to solve it quickly. Great, thanks for watching.